Hello? Hello?
Left and right behavior. Yep. All right, so we are done with the sketching of the sketching polynomials, the polynomial inequalities. Now let's go back to the notes and let's take a look at rational inequalities. So what if your inequality is not a polynomial but instead a rational function or a rational expression, but you're still dealing with the same four possible inequalities? The method is somewhat similar to what we just did, but there's some differences. We will have to move everything to one side of the inequality so that we get a rational expression on one side and a zero on the other. But there's this additional thing that may happen. We might have to get a common denominator to make it look at like one big fraction. You'll see when we go through the examples. After we've done that, we find where the x-intercepts and vertical asymptotes occur. Now remember, when we were studying rational functions, the x-intercepts, you set the top equal to 0. The vertical asymptotes, you set the bottom equal to 0. We're going to find those two. We're going to find where those two things happen. Then we're going to make a number line. We're going to break up a number line based on those answers. And then we're going to use test points, just like we did when we did the rational functions. Remember, we had to break it all up, and then we had to plug test points in. We're going to have to do the same thing here. So we're not going to draw a graph to do this one. The reason why is because drawing a graph for a rational function takes a lot of time. The polynomial is pretty quick. Bounce, touch, right, cross, whatever, and we're done. With the rationals, we don't want to be drawing all these and trying to figure out where it goes up and down and all that junk. So we just get straight to this test point idea. So here are some examples. Let's work these out. So looking at this, you have to first identify that this is a rational inequality and not a polynomial inequality. Is it obvious to you that this is a rational inequality? Yes? The left side looks like a rational function? Yes, it is. Thank you. So this is a rational function right here. Right? It's a numerator polynomial over a polynomial. So the first step was to move everything to one side and so that we get a 0 on the other side. We might have to get a common denominator. Well, do you have one fraction on the left side? Is it one big fraction? Yes. That means you don't need common denominator. Sometimes in the future we'll have two things, we'll have to put them together first. So we are done with the first step. Okay, the first step is good here. The second step is to find where the x-intercepts and vertical asymptotes occur. And I also say omit holes. Remember where we have holes? Wherever you have a common factor on top and bottom, you cancel those out. All right? If we had that happen, we would want that cancellation to occur also. And also, you don't have total asymptotes. That's right. So we won't want to count those. So that's why we omit those. Now, we don't have that in this case because these aren't common factors. So let's get the x-intercepts. Where are my x-intercepts? I set the top equal to 0, which means x is -7. Okay, so that's one of the points I'm going to have. I need to find out where my vertical asymptotes occur. That's where the bottom is 0. So when x is 4. Understood? So are we done with step 2? Yes. Now, step 3, break up a number line into intervals using the points that we just found in the previous answer, or in the previous step. So what I'm going to do now in step 3 is I'm going to draw a number line. I'm going to plot the 2 points that I have, -7 and 4. Now, there's something very important here, very subtle but important. An x-intercept means my graph touches there, right? I mean, it's on the x-axis. So I would like for you to put a solid dot here. Now, x equals 4 is a vertical asymptote on my function, which means that my graph does not exist there, right? It does not exist. So I'd like for you to put an open circle here. That means that it can never be, your graph can never exist at that point. I'll put the dotted thing in here just to remind you of the reason why it's open. It's because in our graph, that's a vertical asymptote. You don't need that, but if it helps you remember. Okay, so have we done step 3? Yes, we broke up the number line. Now, pick random points within each interval, test it with the original inequality to determine the solution set. So what I'm trying to do here, remember the problem is, well, I have it here. The problem is to figure out when this thing is bigger than 0, right? So what I'm going to do is I'm going to pick a point, anything I want, to the left of -7, anything I want between -7 and 4, and anything I want to the right of 4. Those are going to be test points. I'm going to plug them into the original inequality, and I'm going to determine whether or not it's true or false, right? Whether or not it works. So somebody give me a number to the left of -7. -8. I'm going to circle this. That's going to be a test point. How about something between -7 and 4? 0, good. Something to the right of 4? 5. Now I'm going to test these into the original inequality, the original problem. So let me test -8 first. So the original inequality is this thing up here. So I want to plug in, I'll write it over here so we can see it, x plus 7 over x minus 4 greater than 0. Yeah, that's what we're testing it into. So replace your x's with -8. -8 plus 7 over -8 minus 4. Is that greater than 0? Yes or no? We're going to answer this question. So the top is what? -1 over the bottom, which is -12. What's a negative divided by a negative? Positive. So this is 1/12. Is 1/12 bigger than 0? Yes, that is true. What this means to us is that everything over here works. What I mean is everything to the left of -7 works. Anything we would try over here would work. Does that make sense or not? Okay. Now I'm going to plug in 0, do the same process, and then I'll be figuring out what's happening between here and here. So let's test 0. So 0 plus 7 over 0 minus 4. Is that bigger than 0? That's the question. This is 7 over -4. Bigger than 0? No, that's a negative number. Negative number is not bigger than 0. So, no. Which means nothing in that region works. I put an X in there. And then I test 5, and I go through the same process. See if I can squeeze the 5 in here. So 5 plus 7 over 5 minus 4, is that bigger than 0? It's 12 over 1, greater than 0? Yes, 12 is bigger than 0. Which means that everything over here works. All right. Any questions right now? Yes. Yes, now let's get to the answer, right? So what we wanted to know was when this thing was strictly greater than 0, right? Greater than 0. What I know is that anything over here works, right? To the left of -7. What about -7 itself? No, because there my function is 0, isn't it? I don't want to include that. So it'll be everything to the left of negative 7. Then nothing in here, right? Nothing in here. But everything to the right of 4 should work. How about 4 itself? Our function's not even defined there. But we wouldn't want it anyway because we want it to be bigger than 0. So how am I going to write my answer? It's interval notation still. Everything to the left of negative 7? Negative infinity to negative 7, parenthesis, union, parenthesis, 4 to infinity. Questions? Everyone have that down? Let me ask you this. What if the problem would have been changed, and instead of this, we would have put greater than or equal to? I would have wanted to include the negative 7, right? But I cannot include 4. Why? It's undefined there. The function has a vertical asymptote. You can't say that 4 can be there because it can't be in the original function to begin with. So your answer would change to be what? Negative infinity to negative 7 bracket union 4 to infinity. Just like this. So I'm going to write that on the next page. This would be negative infinity to negative 7. This time bracket, I'll do it in blue because that's the difference. Union, everything else stays the same. Yes. Yes, because if you say in your answer, yes, go ahead, include 4, right? You put a bracket here. You say, go ahead and include 4. If I try and plug 4 in here, I get division by 0, which is where our vertical asymptote occurred. So that's not allowed. Now you could plug negative 7 in because negative 7 plus 7 is 0. 0 on top's okay. Understand? Okay. All right. I'm just curious if you could do this one. What if I had changed it to less than or equal to? I'm stretching a little bit here. Let's see if you can extrapolate this. See, here it was positive and positive, right? Above the x-axis here and here. And here we said no. That meant it was below, right? So wouldn't we want this now and not these two sections? And I'm saying where is it less than or equal to 0? So you would want the negative 7, right? But you can never include the 4. So it'd be everything between negative 7 and 4, including negative 7, not including 4. So it would look like this. Bracket, negative 7, comma, 4, parenthesis. Okay, that's good enough. Let's move to the next example. You were missing this over spring break, weren't you? You were like, can't wait till Tuesday. So is this a rational inequality? Yes. Okay, first step is to move everything to one side and make sure that you have one big fraction on the left side. Well, I have one big fraction, don't I? Okay, so first step's done. The second step is to do what? X-intercepts and verticals. So where's my x-intercept? Negative 1 and 4. So I'm just doing this by visual inspection because the numerator was already factored. I set each factor to 0. How about my verticals? 0. Set the denominator equal to 0, x equals 0. That's your answer, 0. Third step is to make a number line and break up that number line using those numbers. So I'm going to use, let's see, -1, 0. Nope. I mean, they're not useful. Yeah, for answering the question we want to answer, they're not useful. Okay, so tell me which of these do I draw solid dots on? -1 and 4. And that means it's 0, it's open. And that's because I have a vertical there. But really what's happening here is we're breaking up our number line into how many regions? 4 regions, which means we're going to need 4 test points. Yeah, something like -2 over here. -1/2, you could say 0.5. Something like maybe 1 in here. And 2, 3, 4. No, I can't use 4. 10, you want me to use 10? Okay. So I've got my test points. I'm plugging those into the original inequality now, and I'm checking to see if it's true or false. So let's test the -2 first. What happens when you plug -2 in right here? -1 times plugging in -2 here, you get -6 over -2. You could, because this one's factored, you could do positive, like you could do that, but only because it's factored. Yes. So I get a positive on top, I get a negative on the bottom. Is that less than or equal to 0? Because that's what I'm checking, right? Is it less than or equal to 0? Well, this will be a positive divided by negative. That's negative. Negative numbers are less than 0. So this works, which means everything over here works. Plug in -1/2. So in the top, what's -1/2 plus 1? That's just a half. And then what's 1/2? -1/2, take away 4 more. Well, it's a negative number, right? Still, -4.5, you could say. It's negative. I don't care. It's over what? -1/2? It was negative right here. That's what we're plugging in. So a negative on top, right? Over a negative on the bottom. Is that less than or equal to 0? No. That means this doesn't work. 1's going to work. So we get 2 here. We get -3. You get 1. So it'll be a negative. It'll work. I'm not going to show it, but it'll work. And then 10 won't work. No, 10 won't work. I thought it was supposed to rain today. It's supposed to be real good rain today. Tomorrow? Tonight? Tomorrow? Okay. Okay. All right, so how do I write the answer? Look, we want to know when it's less than or equal to 0, right? We know that this region over here works. So that's -infinity all the way to where? -1? Included or not included -1? Included. And I can include it because it's a solid dot, so it's possible for me to include it. So -infinity to -1 bracket union. Now I need the stuff in between here and here, between 0 and 4. Do I include 0? I can't include 0, right? Because it's a vertical asymptote. Do I include 4? Yes, because it's part of my x-intercept. Parentheses on 0, bracket on 4. Anything else? That's it. right? We're done. What time is it? Yes, sir. If you had a hole, you would cancel it in the beginning, and you would not include it on your number line. Okay? Well, hold on. Take that back. You would treat it like a vertical. Treat it like a vertical because you can't be defined there because you get 0 over 0. So you would include on your number line. The thing is, I'm not going to give you any holes in inequalities. The book doesn't give you any holes either in the homework problems. But if that were to happen, you would want to include it on your number line because you can't have that point as part of your domain, so to speak. And denominator. It would whatever the factor was, let's say it was x minus 2 on top, x minus 2 on the bottom. That means x equals 2 as a whole. So you would have, it would almost be like a vertical. It couldn't be part of your answer. It wouldn't be a vertical, but it couldn't be part of your answer. You couldn't say 2 is okay to plug in because 2 is not okay to plug in. So you'd have to remove it from your solution set. Again, I won't give you one like that. All right, let's look at, man, I have a lot of these. Let's look at C. All right, do we have a rational inequality? Yes? Does everything move to one side with 0 on the other? The left side's one big fraction? Okay, step 2. What about the x-intercepts? 3, that's it, right? It's the only one. It's a repeated factor. What about the bottom? You'd have to factor this. X minus 6, x plus 5. So 6 and negative 5. So the third step is for me to make a number line. Am I going too fast, or are y'all okay with this? We're okay? I put my numbers on here, negative 5. Let's see, 3 would be next, and then 6. Which of these are solid? Just 3. Open at the negative 5 and at the 6. Those represent verticals. And I've broken up my number line into, again, 4 regions. I have to have 4 test points. So what test points would you like here? Negative 6, that's fine. 0, 4, 7. I'm going to go through this fast, okay? I'm just going to check them mentally. You could do it on your own, do you think? Yes? Let's try negative 6. So negative 6 in here, does it really even matter what happens in here? It's going to be squared, it's going to be positive no matter what. The top's always positive, isn't it? Okay, so let's just plug negative 6 in. I'm going to plug it into the factored version of the bottom here. So negative 6 here would give me a negative 12. Negative 6 here would give me a negative 1. So I have a negative and a negative multiplies to be a positive. And the top was positive. So positive over positive is positive. Is a positive number bigger than 0? Yes, so that should work. What about 0? Does 0 work? Again, just check the bottom. Negative and positive is negative. Right? Plug in 0 here, you get negative 6. Plug in 0 here, you get 5. Multiply the 2, you get a negative. Positive divided by negative is negative. That's not bigger than 0. So this wouldn't work. What about 4? Negative and positive is negative, and the top is positive, so it's so that doesn't work. Ah, look, you thought there was a pattern, didn't you? You thought it was always going to switch, didn't you? So it didn't. And then you try 7. 7 works. So you want to go all the way, everything over here, all the way to negative 5. You cannot include negative 5 no matter what, because it's a vertical. Everything from 6 on, you cannot include 6 no matter what. So what do we got? Negative infinity to negative 5, parenthesis, union, 6 to infinity. Done. So the level of excitement in this room is, you can feel it, you can touch it. All right, so look, up to this point, we haven't run into any issues algebraically. This next one, please pay attention to, because you're going to have some issues. So just when you're starting to feel pretty comfortable, there's this. Okay, so notice that the right side is not a 0. And the first step is to move everything to one side. So you got to move that 3 over there. And the only way to do that is to rewrite this rewrite the 3 as 3 over 1. We will, yes, but just make sure we're all okay with this step. Just move the 3 over by subtracting it on both sides. And that 3 is by itself. It doesn't go up here with this x minus 2. It's its own term over here. Now, this is not the rational expression that we need on the left side, because we need it to be one fraction. Right now we have 2 fractions. This minus, this is like 3 over 1. It's like 2 different fractions. We need to put them together, which means we need a common denominator. So I'm going to write x plus 2 over x minus 8 minus 3 over 1 greater than 0. So my common denominator, I look at my 2 denominators, I need these both to be x minus 8s, right? So what I do is I introduce an x minus 8 on the top and bottom of this fraction. I'll do it in blue. X minus 8 on top, x minus 8 on the bottom. Let me rewrite the next line. X plus 2 over x minus 8 minus, tell me what my new fraction over here is going to be. 3x minus 24, I'm distributing that 3 through, over the common denominator, x minus 8, greater than 0. Now we can put these two together, can't we? Because they have the same denominator. So what we do is we do x plus 2, then we subtract everything here. And what do you have to be careful with when you subtract something like this? Change the signs of both. So it's going to be x plus 2 minus 3x plus 24. Please take special note that that negative will have to pass through to both of those when you get to this step. All over the common denominator, x minus 8 greater than 0. Now get your collected like terms up top. Bless you. You get negative 2x plus 26 all over x minus 8 greater than 0. Okay, so everything we've done up to this point, right here, all this work that we've done was just to get it to look like this problem right here. See, we had something over something greater than 0. We had to do all that work just to get it to be something over something greater than 0. Now we may proceed with the rest of everything. So step 2, find the x-intercepts, set the top to 0, right? That means x is what? 13. 13. So move your 26 over, it becomes negative 26. Divide by negative 2, you get positive 13. How about vertical? 8. Step 3 is a number line. I have 8 on this number line. I have 13. Which of those are solid? 13, open dot is the 8. I've broken up my number line into 3 regions, and now it's test point time. This will be interesting. Where are you going to test these points? I say in the notes to go to the original, don't I? You can do it into this one. All right? The only issue that you might run into is, what if this is wrong? Well, then this is probably going to be wrong anyway. But so it really doesn't matter. I'm going to pick something to the left of 8. I'm going to pick 0. Between 8 and 13, I'm going to pick 10. To the right of 13, I'm going to pick 14. Okay. Let's plug 0 in. Let's do it right here. What happens when you plug 0 in? 26 over negative 8? It's a negative number. Is a negative number bigger than 0? No, so that doesn't work. How about 10? Negative 2 times 10 is negative 20 plus 6. It's positive 6. 10 minus 8 is 2. Positive over positive. It's going to work. It's bigger than 0. 14? No. Someone want to tell me what the answer is? 8 to 13. Parentheses on the 8 and the 13. Why did I not bracket the 13? It's a solid dot. Because the original inequality was greater than, strictly greater than, right? Okay, so this is it, 8 to 13. I haven't polled you in a while. Let's see if you're okay with that. All right. This will be probably our last one. I don't know if we'll have time for the next one. Does that look like a rational inequality to you? Yes? We need to move everything to one side, though. So how about I take the 5 over x minus 3, leave it there, bring the 3 over x plus 1 to the left side, leave it as greater than or equal to 0. Now, what do I have to do? I have to get a common denominator. That's right. So we have to introduce what here, top and bottom? X plus 1. And then over here, top and bottom, x minus 3. I'm also going to put parentheses around the bottom because there's 2 terms. Let's distribute out the top here. 5 goes through here, so I get 5x plus 5 over my common denominator. Don't multiply it out. Just leave it. Minus, multiply your 3 through here, 3x minus 9, over your common denominator. All of this has to be greater than or equal to 0. Combine these together now. Be careful with that negative sign. Goes through. So 5x plus 5 minus 3x plus 9, right? All over. Do y'all think Kentucky's going to win it all, or do you think they're going to get upset? Upset, you think so? I think so too. I don't know who though. Yeah. Yeah. All right. What's next here? Okay, put them together. So 2x plus 14 all over x plus 1 times x minus 3 greater than or equal to 0. Now, at this point, we've got into one rational expression on the left, one big fraction. Now we can continue with the process. You think you can handle it from there? Okay. I think it's a good place to call it a day. We'll end a little. Well, I'll end early, but I'll talk about something quickly, since it is what the tournament starts tonight, doesn't it? Okay, so the standard, the first round, just to get the final bracket of 64, right? Oh, and tomorrow. No, this is just kind of a little interesting fact. Y'all know the brackets. Okay, you may not even know what I'm talking about. Men's college basketball every year does a tournament. It's called March Madness. So they basically have 64 teams, although they've expanded a little bit. They have 64 teams, and they have a tournament. You win, you go on. You lose, you go home, right? And they play each other, and then at the end, you have the champion. All right. If you take the bracket right now that shows the teams that are going to play each other, and you try and pick who's going to win each game, then who's going to win that, and then who's going to win that, and you try and fill out the entire bracket, I think last year Warren Buffett offered like $1 billion to anyone who could fill. It was a lot. It was like $1 billion to anybody who could. Okay, so that's what I'm talking about. So let's $1 billion, right? If you could fill out the bracket correctly before the tournament starts. All right, so let's just talk about this real quick. So here's game one, all right? You have Team A versus Team B, all right? They play each other, and either Team A or Team B is going to win, right? Now, of course, you could say this is, Kentucky versus UTSA, and you can probably say, Kentucky's going to win or whatever. But if you're just really trying to figure out, like, how many different ways can a bracket be filled out, then there are two ways that this can happen, right? A can win or B can win. Now, that can happen for each of the first round games. How many games are in the first round? Well, there's 64 teams, so 32 games. So if there's two ways to win this game, and two ways to win the next game, and two ways to win the next game, you have to multiply those together to get the number of ways that can happen. So that's 2 times 2 for each of the 32 games. That's 2 raised to the 32nd power. That's how many ways the first round can go. Then you have the second round. So how many teams are left after the first round? They went from 64 down to 32. They play 16 games. There's 2 ways each of those 16 games can happen. That's 2 to the 16th ways that can happen. Then you multiply that times, now you have 16 teams, right? There's 8 games, so there's 2 to the 8th. Now you go down 2 to the 4th, 2 to the 2nd, 2 to the 1st. Okay, so let's add up these exponents, because that's what you do when you have the same bases. You add them up. 32 plus 16, 48, 56, 60, is that 63? 2 to the 63. Okay, so let me come in here now. What is 2 raised to the 63rd power? Yeah. That's how many different ways you could fill out an NCAA bracket. All right? So, yeah, let's try and figure out what this is, right? This is millions, billions, trillions, gazillion. What is that? Austin Powers, where he's like a gazillion, 9 gazillion. All right. Well, look, let's just go with this. How many people are on the planet? Billion. Okay. So let's say 36 billion right here, right? You want to say 6 billion? Whatever. It doesn't really matter. But if you take this, let's just say 7 billion. I'm going to take that number. I'm going to take that number right there. I'm going to divide it by 7 billion. There we go, right? That's 7 billion, isn't it? Okay. That's not what I want. Okay, so it's 131 with 10 nines, so, or 10 9 0. So 1 3 1 7 6 2 1 2 3 1 2. All right. All right. So what's that number? 1 billion. Okay. So if no, it's so here's what this means. This means that in order to guarantee that someone gets a bracket correct, every person on the planet would need to fill out 1,317,000,000 brackets, and every single one of those would be different. So your 1 million or 1 billion brackets that you fill out are going to be different than my 1 billion and your 1 billion. Everyone on the planet has to do that to guarantee a winner. All right. So the odds of doing this, you know, if you look at this number here, 1 divided by that number. I mean, that's the probability. Move this decimal point 19 places to the left, and that's the percentage. It's astronomically small. I mean, it's such an I mean, the probability of randomly filling the bracket out correctly is, you probably have better odds of leaving here, getting struck by lightning, going to the store, winning the lottery tonight. Tomorrow, you get struck by lightning again, and then you win the lottery again the next night. That there's a chance, right? It could happen, right? It could happen. So that's why Warren Buffett was willing to give $1 billion to anyone who filled it out correctly. Now, who has the record? I think the record is to get the first 2 rounds correct. I think that might be the record. Someone got the first 2 rounds correct. Missed 1 game on the second round or something? Yeah, we'll have to research it or something. But anyways, no one's got the Sweet 16 up to the Sweet 16 correct. No one's been to the grade 8. No one's even got close to the Final Four. You submitted online before? Hey, what about homework? Hey, hold on. Homework. Why don't you try the homework out of the book? Okay, the 5.4 homework. Try it out. I do not have the solutions posted, but try those out. I'll see you on Thursday. Have a good day.